this video we will be explaining linear perspective. There are two kinds of perspective, linear perspective and aerial perspective. The two important features of linear perspective are objects appear smaller as their distance from the observer increases, and foreshortening is to represent a line, form, or object as shorter than actual length in order to give an illusion of recession or projection in accordance with the laws of linear perspective. Let's look at the first feature. Objects appear smaller as their distance from the observer increases. We can see all these lines in this airport converging on one point, and that point that they converge to is called the vanishing point. This point right here is the vanishing point. And as you proceed along the lines toward the vanishing point, objects appear to get smaller. Let's look at the people in this image who are all relatively the same size. As you can see, as we move into the distance toward the vanishing point, the size of the people decrease considerably. This man and this man, if they were standing next to each other, they're all the same size. But as you can see, they appear to get smaller and smaller as they move into the vanishing point. In other words, they're all going to eventually vanish also. Now let's look at this building outside. At first glance, you wouldn't guess that all these lines point to the same spot, but they in fact do. We'll draw these lines along the side of the building and follow these lines, and you can see that all of these lines point to one spot, the vanishing point. Even up here in these towers, just check this line here, from here to the vanishing point. It follows the lines. Now let's check the sidewalk from this point to there, and sure enough, the line follows the vanishing point. Now you'll also notice that the vertical lines on the building are perfectly plumb. That means they go straight up. Even though the lines on the side of the building are pointing toward the vanishing point, the vertical lines are still perfectly vertical or plumb. So the vertical lines in a vanishing point perspective are not distorted. Now the vanishing point is on the horizon. This line right here is the horizon. This is what we call the true horizon. Now the visible horizon is where the trees meet the sky up here, but the true horizon is at eye level when you're looking at an object or an image. I'll show you what I mean. To determine the horizon line, hold your brush at arm's length, close one eye, hold your brush level, don't go higher and don't go lower. Hold it at eye level and look through the brush, and you'll see the horizon line, the true horizon line. Sometimes the visible horizon line will hide the true horizon line, but the true horizon line will be right through your brush. So here's the concept from a distance. I'm looking through my brush into the distance, and there's the vanishing point, and these green lines would represent something like trees or people as the distance increases from the viewer to the vanishing point. Now here's what I mean by the visible horizon line. These points right here are the visible horizon line, where the sky meets the ground. But the true horizon line, when I'm standing out in this field looking at eye level, the true horizon line is going to be through these mountains. So if I'm painting a building, I want the perspective to be pointing at the true horizon line, not the visible horizon line. So I hold my brush out at eye level, and right there is the true horizon line. Of course, the true horizon line is much easier to see when you're looking at the ocean because it's completely and totally level. So as you can see here, the true horizon line is the water line. Another thing to remember, the sky also is affected by perspective. Let's look at this landscape. Here's the horizon line. Put some mountains in the background. Here's some trees that are obeying the rules of perspective. You can see the trees are getting smaller as they recede into the background toward the vanishing point. Let's put some perspective lines in the sky, and notice how the clouds get bigger as they come toward you, or conversely they get smaller as they're going away from you toward the vanishing point. So the clouds also will diminish in size as they move toward the vanishing point. Many people will make big white clouds any size and put them in the sky, and then they wonder why their landscape looks funny. And it's because the sky does not have perspective in it. So remember when you're painting clouds that they also diminish in size as they get further away from the eye. Now let's look at how perspective affects a building. So this is single point perspective. And this only works if you're standing directly in front of a building where the front of the building is square. Here's you. Here's the horizon line. Here's the vanishing point. Let's draw lines from each corner of the building to the vanishing point. This is called single point perspective. And then here's the building. It appears to get smaller as it moves into the distance. Now let's talk about two-point perspective. This would be if you were standing at the corner of a building and you were seeing a vanishing point going in two different directions. You'll see what I mean when we draw this. Here's the corner of the building. Here's the horizon line. There's a vanishing point here and a vanishing point here. You can see we're standing at the corner of this building. It appears that the building is getting smaller as it moves toward the vanishing point in the distance. And this is a conflict for your brain because your brain knows the building is square on each side, and yet it seems to be getting smaller as it recedes into the background. So you have to believe the right side of your brain this time. Believe what you're seeing, not what you know. Now let's look at a two-point perspective, but we'll raise our point of view up higher as if we're on top of another building looking down at this building. So here's our corner of our building. Here's the horizon line. Notice the corner of this building is perfectly vertical. Here's the vanishing points. Vanishing point here and a vanishing point here. Now let's draw the other two corners of the building, and you'll notice that they are also perfectly vertical. They're not affected by the vanishing point. Now we draw lines from the top of the building to the vanishing point. So now we're seeing the top of the building as well. And remember, each side of this building is square, but it appears that it's getting smaller as it recedes toward the vanishing point. So we end up with this box that we know is square on each side and the top, but it doesn't appear that way. Here's a perfect square with 4 right angles. Each one of these corners is a perfect 90-degree angle. And that's the way our box is. Each side and the top is square, but that's not the way it appears. So remember, when you're drawing, you have to believe what you see, not believe what you know. The left side of the brain knows this box to be square on all sides, but the right side of the brain is seeing it as it appears. In fact, we can separate each one of these sides. There's not a single 90-degree angle on any of these angles. We'll pull our box over to check the right angle. As you can see, none of these angles is a right angle. Again, it's a conflict for our brain because we know that the building is square on each side and the top, and yet there's not a single right angle on it that we see. So again, this is just another lesson in learning how to see. Believe what your right brain sees. When you're drawing, don't believe what your left brain knows to be true.